Good morning, students. Good morning, all of you. Good morning, students. Last day, what we discussed? Can anyone reply to me? Pi of 4, Pi Z4,
Introduction to dbms, sir.
Introduction to dbms. So, what are the topics we discussed in introduction of dbms? What is data? What is database? What is database management system? Advantages of database management system. Then the difference among file system and database management system, right? What is
Yes,
data?
sir.
What is data? Data means some
Hello.
information, right? Information means what type of information it is. Either it is a text file, doc file, audio, video, images, everything is data, right? That data we can store in database. What is data? What is data, ma? What is data?
Collection of information.
Collection of information. Can you give some examples? Data means what type of data?
Alphabets, numerics.
Okay, means audio, video. Is it data or not? Images, that is also data, right? So everything is data here. So that data we can store in database. We can manage it. We can do multiple operations. So data means information. So that will be in organized manner, unorganized manner. Previously we are using file system, right? There it is unorganized manner, means that doesn't follow any structure. Okay, database means data means information. Database means organizing collection of data. Database means what? Collection of data, collection of interrelated data, collection of interrelated data, right? Database management system means that is a software, ma. Database management system means what? Software. See, we have MySQL software, Oracle software, SQL Server software, Sybase. So all are database management system softwares. Why we are using database management system softwares? We can store data in easy manner in structure way. Okay. However you want to store, you can store. However you want to view that, you can view. It provide easy way to use. Database management system is a computer software application. What it does, interacts with the end users, other applications, and the database itself to access, update the data, manage the data, and we can analyze the data with the help of set of application programs, right? So that is under database introduction. So what are the advantages of database management system? Data is independent. So we can access the efficient data and the data integrity, and we can provide security to that data. Data administration we can do. Then concurrent access and crash recovery. Reduce application development time also we can reduce. Within the less time we can do multiple operations by using database management system. So in which applications we are using database management system? Which applications? Where we are using our software? Anywhere, like airlines and railways, banking sectors, education sectors, telecommunication sectors, e-commerce applications, human resources, anywhere we are using our software. So I said right, previously we have file system. So what are the drawbacks from file system? Why we are using database management system? I said some differences and drawbacks from file system, advantages of dbms. So what are the advantages of dbms? We can avoid the duplication of data. In dbms we can avoid the duplication of data, right? There we can avoid redundant data. Redundant means duplicate data. Through how we can avoid duplication of data, redundant data? By using normalization concept. By using normalization, like first normal form, second normal form, third normal form. So in this way we have normal forms. We can avoid redundant data, data inconsistency problem, everything we can avoid by using normalization. Okay. See, data consistency and integrity. So data consistency means, see, previously we have file system. One file is using by someone. The same file, if I want to use it, we can't, right? So more than one people, they can't access that file. They can't perform multiple operations. But by using by database, we can perform multiple operations. Like I can access, you can access, some other one can also access. That is the main advantage of database, right? So if anyone accessing the data must be available, right? That's what data consistency. If I want to access the data, it must be available in the database. If someone want to access, it must be available. That's what data consistency. And integrity. Data normalization take care of it too. So data normalization can taking care of data consistency, data integrity, and data redundant. And what is another advantage of dbms? Security. So each user has different set of access. Each user has different set of access, and we can provide privacy. Privacy means limited people only can access. Limited people only can access, and easy access to data. Easy access to data and easy recovery. Data we can recover if sometimes any crashes occurs. Data is not available. We can back up the data. That's what easy recovery, and it is very flexible. These are the advantages of database management system. I given the differences between file system and database management system, right? So what are the differences, ma'am? Tell me some 4 differences at least, main differences. Already discussed in advantages, right? Data redundancy problem in the file system, data consistency and integrity, no data consistency and integrity. Next, no security. These are the main drawbacks from the file system, right? and accessing is very difficult. Data integrity problem there. These are the drawbacks from the file system. These are overcome by the dbms. We can avoid data redundancy problem, data inconsistency problem, data integrity problem, and security data inconsistency problem by using which concept? Normalization. Which concept? Normalization. In the normalization, we have different types like first normal form, second normal form, third normal form, and fourth normal form. So in this, we should follow some rules to avoid redundancy problem and data inconsistency and integrity problems. Okay, we will discuss the topics later. Okay, so what are the examples of dbms? Dbms is a software, right? So what are the softwares we have? We have MySQL software, MS SQL software, Oracle software, DB2 software, NoSQL software, next Sybase. So we have so many softwares. In file system, NTFS, F8T32, and some in COBOL also we are using file system. Okay, that's our old. Now our topic is view of data. Our topic is what? View of data. So how we can view the data, how we are storing the data in database, which people we can view the data, which data we can show to the users, which data we are hiding. So this information we can see here. View of data. In this we have three concepts. Abstraction, view of data. In this we have three concepts: abstraction, data abstraction, instance, and schema. Abstraction means what? Abstraction means hiding. Hiding means what? No one can see that data, right? Abstraction means hiding. Data abstraction means data hiding. Hiding the data. Which type of data? Which data we can hide? If it is unnecessary to me, I can hide the data and I can see only particular details. I can I can see only my data. Hiding the unnecessary details and showing necessary details. Hiding the unnecessary details and showing the necessary details. That is called data abstraction. Right. Instance means instance and schema. Instance means one object. Like for example, we have one entity. Entity means also object. Like we have car, bus, lorry. These are the entities, right? So bus having some properties means attributes. We call it as attributes. Bus ID, bus name, bus route. So many properties we have regarding to the entity. Thus we are calling here as attributes. Entity attributes. Okay, these all are in database, that is called schema. See, one by one we will see. Abstraction. Abstraction means hiding. Abstraction means what? Hiding unnecessary details from the user and providing abstract view of data which is required to the users. Hiding unnecessary details. Hiding unnecessary details. For example, in bank, so if I ask for show my details, so they are asking my bank account number. If I give that, so they will show all my details, not all users of details, right? Bank have a number of customers. All customers data they will show to me? No. Only my data I can see. That data provided there. So that is called hiding unnecessary details from the user and providing abstract view of data which is required to the user abstraction, right? Next, what is data abstraction? Database systems are made up of complex data structures. Database systems are made up of complex data structures to ease the user interaction with the database. So every user trying to interact with the database, the developer hide irrelevant details from the user. The process hiding irrelevant details from the user is called data abstraction. Means what? Hiding unnecessary details, showing only the necessary details regarding to that user. Hiding the unnecessary details, showing necessary details to that user. Right, that is called data abstraction. Next schema. Design of database is called schema. Schema means what? Designing database. You can design the database. Like how much we can store, which type of data, which structure we are storing. So that database design called as a schema. How many types there? How many types of schemas there? Physical schema, logical schema, use schema. What are the types? Physical schema, logical schema, use schema. So physical schema means what data users and applications programs see. Users able to see the data, right? That is physical schema. Logical schema means what data is stored. That means it describes data properties such as data semantics, data relationship. What type of properties? See, a student having student ID, student name, college name. Next, so many properties will be there, right? Student address something. So student address is some another table we are providing. One table to another table, relation between one table to another table. Okay, that all relations and everything is logical. We can't see, right, that relationship, semantics and all. So that is called logical schema. That is called logical schema. What data is stored? What data is stored? That is logical. Okay, what we are unable to see, that is all logical. The relationship, data schemas and all. Okay, next physical level. Some physical level, how data is actually stored. How data is actually stored, or we are using disk, which any file system. Physical level. In physical level, what we are doing? How data is actually stored. How data is actually stored, or we are using disks. So we are previously how you are storing the data in pen drives, disks, something, right? So how you are using disks, which are file system or not? So we can see. So that is called physical level. Physical level. Next is what? Data models. Data models. Data models means how we are storing data into the database, what structure it is, what are the attributes, entities and the relationships we are maintaining, what are the constraints we are using. So these are designed in data model. These are designed in data model. Data models determines the logical structure of database. Logical structure means what? Logical structure means designing the database. We are designing the database. How? Designing the database how? So we are dividing number of entities, each entity having attributes, and the relationship between entities and attributes, okay, and constraints. These all we are decided in data model. These all we are decided in data model while designing the database. You understand, right? Data models means what? Logical structure. What? Logical structure. One word you can remember. Data model means we are designing determines logical structure of database. Logical structure means what? To design a database, we need what? Number of tables, right? Each table having table name. So that is called what? That is called what? Entity. Here table means what? Entity. The table having attributes means properties, right? For example, you are a student. Student is a table name. That is called entity. Student is a entity. Student is a object. Okay. So that student having properties. Student ID, student name, student college name. Next to student address, right? These are the properties of means attributes of student. So student, how you can create the table? By using entity name. Entity name here is what? Table name. And properties means attributes like student ID, student name, student address. Next, in the same way, you are creating another entity, college. College ID, college name, college address. And relationship between college and student. Okay. The relationship between students and college. These all we are decided in the data model. Data model. Constraints means constraint, not null, unique, not null, unique. It's primary key, foreign key, check constraint. These all are constraints. For what purpose we are using? So to avoid the invalid data, to avoid the duplicate data. By using primary key, we can avoid the duplicate data. We can allow only unique data, right? Primary key, foreign key, then not null. By using not null, we can avoid the null values. We can avoid the null values while storing data into that table. While storing data into the table, we can avoid null values by using not null keyword. So these all are constraints. When we are creating the database, so we should design in this way. Okay, by using data models. Okay, so how many types of data models we have? We have so many, right? Relational data model, relational data model, entity relationship model. Second one is what? Entity relationship model. Next, hierarchical data model, hierarchical data model. Next, network model, network model. Next, object oriented model, object oriented model. Next, object relational model, object relational model. Semi structured data model, semi structured data model. Flat data model, flat data model. How many there? Nearly 8. Nearly we have 8. Relational data model, entity relationship model, hierarchical data model, network model, object oriented model, object relational model, semi structured data model, flat data model. Okay, let us see. Let us see hierarchical data model. Hierarchy means what? Tree structure. Hierarchy means what? Tree structure. We are arranging data in tree structure. Tree means what? It contains one root. That root contains number of branches. The branch contains sub branches. So we are arranging data in a tree structure, that is called hierarchical data model. That is called hierarchical data model. A hierarchical database model is a data model in which the data is organized into tree, in which the data is organized into tree like structure. Okay, like a tree structure. The data is stored as records which are connected to one another through links. The data is stored as records. How data is storing in records form? So one row is one record here. For example, student, one student table contains student ID, student name, student address. So student ID is 101, student name Shiva, and address is HYD. Next another name, another ID 2, next student name Praveen, and address is Andhra. So what we are called record here, each user data we call as a record. For example, Siva. So ID is 1, name is Siva, and address is HYD. This is one record. Next record is what? Second record to Ravi, Andhra. So each row is one record here. The data is stored as records. How is storing? In records, which are connected to one another through links. Each one connected, interlinked. Each are interlinked. A record is a collection of fields. Record means what? Collection of fields which each field contains only one value. Each field must contains what? Only one value. Each field contains only one value. So that is called record. A record is a collection of fields. Okay, collection of fields means ID, name, address. One user ID, one user name, one user address. Okay, so that is called record, right? Hierarchical data model represents what, man? Tree structure. If you are arranging data in tree structure, that is called hierarchical data model. Now we are not using this hierarchical and relational and all, so you will see. Okay, next example of hierarchical model. How we are arranging the data, we can see by using this diagram. So what is the root node? What is the root node here? Department. Department having sub branches, course and student. Department having course and student. Next, course also having another sub branch, professor. See, department having what fields, ma'am? What fields department having? Department number and department name. That having two childs. Department is parent, that having two childs, course child and student child. Students also, course also contains properties, means attributes. In database we call it as attributes. See, course number, course name, course unit. Next, student having student ID, student name, student course. In course we have another branch, that is professor. The professor having professor ID, professor name. In this way we can design hierarchical model. We can design hierarchical model. You understand, right? Hierarchical model. Hierarchical model means just it is a tree structure. It follows tree structures. Tree contains what? Root node, sub branches, branches that contains sub branches. Okay, each node contains their properties. Each node contains their properties, like department number, department name. From course entity we have course number, course name, course unit. In student entity we have student ID, student name, student course. And professor entity we have professor ID, professor name. Right, you can understand, right? Next, see example of hierarchical model, hierarchical database model. See, we have root node. Root contains child. Child contains another child. Okay. So in this way we can design it. In this way we can design it. It must be in tree structure. Hierarchical means what? Tree structure. We follow tree structure. We design database in tree structure. Okay. See, for example, real world example, employee. Employee is a root node that contains sub branches. Branches contain sub branches. Employee is a root entity that contains permanent employee, contract employee, intern employee. So and permanent employee having manager and software, manager and software. So in this way we follow tree structure in hierarchical model, follow tree structure in hierarchical model. Can we see the network model? Network model. See, in the network model, entities are organized in graph. Entities are organized in which format? Graph format. Which format? Graph format. In which some entities can be accessed through several paths. How we can access? In which some entities can be accessed through several paths. By using path, we can access the entities. Network model means what? Entities are organized in graph format. There entities are organized in a hierarchical model. Entities are organized in tree structure. In network model, entities are organized in graph. Graph. Okay. Network data model example. See, let us see the example. Department is entity, student is entity, course is entity, professor is entity. So each one is interlinked, right? And the properties also interlinked. See, department name, the course name, next student name, professor name, everything is interlinked. That is called network. Network means what? Actually, network is what, ma? Connecting multiple computers, connecting multiple computers at a time, right? Connecting multiple computers. In this way we can connect multiple entities here. We can connect the multiple entities and we can share the data. We can share the data. So that is called network data model. So example also there, store there, store having customer, manager, salesman, and customer order, manager order, salesman order, then salesman items. So everything is interlinked. Example for network model, we can see how the network model will be. In this way we can design that our database means in graph name. Okay, that is called network model. Let us see object oriented model. Let us see object oriented model. Network model, you understand, right? Nothing, ma. That is graph. You follow graph structure. Hierarchical model, we follow tree structure. Okay. In object oriented data model, object oriented data, everything is object here. Object oriented means what? Everything is object. I said right. Entity means here object. Entity means here object. We call there it as entity. Now it is called as object here because it is object oriented data model. Everything is object here. This data model is another method of representing real world object. Object oriented means real world object. We are using real world object. See, for example, in every program we use some commands. Those are not understood by other persons, right? But we can understand by using object oriented because we are using real world entities like car, bus, college, student. These are everywhere we are using, right? We can understand. Student means we can understand. But in another programming, you see, for example, Linux there, Linux or some commands there, we need to remember it. Those are not object oriented, right? Here object oriented means we can use real world entities like car, bus, elephant, trains, everything is object here. You can easily understand, we can easily remember everything. So that's called the object oriented. Object oriented means what? We are using real world objects, real world entities, right? It considers each object in the world as objects and isolates it from the each other. It considers each object in the world, each object in the world as objects and isolates it from each other. Isolate from each other. It differentiates each object. Okay. Next, it groups its related functionalities. It groups its related functionalities together and allows inheriting functionality to other related subprograms. To other related subprograms. Object oriented means what? So we can use the real world entities, and mainly we have inheritance concept. Inheriting means what? Acquiring properties from one entity to another entity. Acquiring properties from one function to another function. How? That's what inheriting. So we have the data in one group. Okay, the data we can use in another group, the subgroup. So parent group there and child group there. If I want to use parent data here in subgroup, so we use inheriting concept. Okay, that's what main advantages from object oriented data model. Object oriented data model we can use inheriting. Inheriting means we can use parent data into child. We can use parent data into child group. So that's called object oriented. That is called object oriented. So how you are designing object oriented, we can see here. See the designing process. See the designing process. So object oriented model. So here we have entity I shape. Next sub subgroups. That means what? Child groups. Child groups contains child entities. What are the child entities? Line, circle, shape list. Line, circle, and shape. So line and child having C point. So another subchild. See how we are interlinked. See, each one is interlinked. I shape is a parent, that parent having childs like line, circle, shape. That means what? I shape can implemented in line. I shape implemented in line. That means I shape having the function. I shape having the function paint. Paint function there, right? Paint function. So that function we can implement in where? Line. That function we can implement where? Circle. That paint function we can implement in shape list. Shape list. So these are child we can implement here. We can do operation here. Okay, paint operation, line paint operation, circle paint operation, shape list paint operation we can do in subclasses. That means what? We are using super group information here. So line having start point, end point, color. Circle having center point, means C point, color and radius. Shape having shape list. So these are the properties. And C point having one-to-one relationship between line and C point, and one-to-one relationship between circle and C point. So x-axis, y-axis. Those are int. What type of data types we can use here? Data types also we should use here. In structured data, if you want to store structure type of data, we can use data types. So what type of data we are storing? Int type or float type, varchar type. What type of data we are storing, we should mention here. So the relationship you understand, right? One-to-one relationship, parent to child. So in this way we can represent. This is called aggregation relationship. So one-to-one relationship between line and C point and C point to line or circle. Okay. So this is called object oriented. Object oriented, everything is object. I shape, line, circle, shape list, C point. And inheritance concept is used here, right? You understand, right? Inheritance concept. I shape having paint function. That paint function we are using in child entity also. In child object we are using paint function. See, line having paint, circle having paint. We are using that paint function here. That means we are implementing paint function in circle. We are implementing paint function in line from shape. Okay, that is called inheritance. Object relational data model. You already seen object oriented, right? Next we can see object relational data model. See, object relational database ORD, object relational database or object relational database management system ORDBMS, ORDBMS. Object relational database management system is a database management system similar to relational database. It is similar to relational database, but with an object oriented database models. Means what? Objects, classes and inheritance are directly supported in database schemas and in the query language. So database means what? What type of language we are using to store data into database, to retrieve data into the database, to manipulate data into database. So what type of language we are using? Query language. SQL we are using structured query language. Everything is query here. Okay. By using query language we can perform operations. Understand? So object relational model, we have an object relational database or object relational database management system is a database management system similar to relational database, but with the object oriented database model. Objects, classes, inheritance are directly supported in database schemas and in the query language. See how See next, semi-structured data model. Semi-structured means the semi-structured data model is designed as a evaluation of relational data model that allows the representation of data with flexible structure. Representation of data with flexible structure. Semi-structured data model means what? Representation of data with a flexible structure. Flexible structure. See, for example, root node is what? Node. Node having number of subnodes like to node, from, heading, body, etc. Right? See the semi structure. This is like a XML. If you know the XML, you can understand it. See, root node that contains number of subnodes like uh, to, form. See, less than, greater than symbol there, right? That is node. Okay, that contains name is what? To, form, heading. So within the braces we can mention it, and in the middle we are writing, that is called data. That is called data. For example, see, for a here entity is, if you compare with our table, node is a table that contains properties to, from, heading, body. That means what? These are the column names. These are the column names. Node is a table that contains to is a column name, from is a column name, heading is a column name, body is column name. That contains the data. So that column, two column contains tau data, from Johnny, heading reminder, body don't forget me, this is weekend, something. So whatever the data we are mentioning in the tags. Okay, this is called semi-structured data model. Semi-structured data model, how we can represent? This is the representation of data with the flexible structure. Flexible structure means semi-structured data model is model which schema is part of data. Schema is part of data. See, now what you learn from these models? Summary of evaluation of database model. Summary, just summary. See the summary. File system. File system is no database model, that doesn't contain any data model. Okay. Hierarchical means what? Tree structure. That means allowing one to many relationship. Hierarchical means what? Tree structure. Tree contains node contain number of uh, child nodes. Child nodes contain another sub nodes, right? So in this way we are following tree structure. Means what? One to many relationship. We are following one to many relationship by using hierarchical data model. Next, network allowing for special relationship. Any special relationship means we can use network model. Where we can use relational model? That means allowing for individual element access anywhere in the database. Allowing for individual element access. If I want to access individual element in anywhere in the database, there I can use relational data model. Where I can use relational data model? Allowing individual element access anywhere in the database. Next, object data model. Where I can use object data model? Handling high speed applications of small data items within large highly complex data sets. Where we can use handling high speed applications of small data items within large highly complex data sets. Okay. Object relational model, where I can use including the most accountable aspects of object database into the structure of relational database model, including most accountable aspects of object database into the structure of the relational database model. Here I can use the object relational model. Okay, think you understand, right? Session is closed. Students, have you understand? Introduction of database management system that contains database management system, advantages of data management system, drawbacks from file system, and advantages of database management system, their differences. Next to data models, view of data. So these we discussed now. Tomorrow we will discuss another topic. Okay, right? Okay, thanks for attending this session. We will see next chapter next class. Okay, thank you all.